Thanks to the incredible James Webb Space Telescope, a discovery once considered routine is now stirring massive excitement across the scientific community. Let me introduce you to LHS 1140b, a fascinating super-Earth located in the constellation Cetus. At first glance, it seemed like just another lifeless exoplanet among thousands. But recent observations from Webb have completely changed the narrative. LHS 1140b might not only have the right conditions for life, it could be one of our best chances yet at finding it beyond Earth. That's not just wishful thinking. It's backed by real data, and scientists are paying attention. Originally discovered by astronomers from the University of Montreal, LHS 1140b didn't appear too special when it was first found back in 2017. Back then, they thought it resembled a mini Neptune, a world wrapped in a thick atmosphere of hydrogen and helium. Not exactly a friendly place for life. But everything changed when JWST got involved. With its powerful instruments, the telescope took a close look at the planet's atmosphere as it passed in front of its host star. What it revealed shocked everyone. That thick, unwelcoming atmosphere? It wasn't there. Instead, something much more familiar and far more exciting showed up. Rather than being wrapped in hydrogen and helium, the James Webb Telescope revealed that LHS 1140b might actually have a nitrogen-rich atmosphere. That's a huge deal because nitrogen is the dominant gas in Earth's atmosphere. If this is true, it suggests LHS 1140b could have Earth-like conditions, and even massive oceans of liquid water. In fact, scientists now think it may be covered with enormous bodies of water, possibly much larger than anything on Earth. And as we know, wherever there's water, there's a good chance that life could follow. That's why this discovery has jumped to the top of everyone's list. What makes LHS 1140b even more intriguing is its size. It's nearly 6 times more massive than Earth. That means its gravity would be much stronger, and life, if it exists there, would have to be very different from what we know. Think about creatures adapted to intense pressure, thick atmospheres, and possibly even ice-covered oceans. Because here's the catch, LHS 1140b is tidally locked. One side always faces its host star, while the other remains in permanent darkness. This creates a planet that looks like a giant frozen eyeball, with the side facing the star possibly hosting vast, unfrozen oceans, the only temperate area. The chance of life existing in that narrow band, between the scorching day side and the frozen night side, is what's making scientists so excited. This temperate ring might be home to strange, ocean-dwelling life forms, unlike anything we've ever seen. And even though the James Webb Space Telescope is our most advanced observatory to date, it's still limited. It can only observe LHS 1140b crossing in front of its star about 8 times per year. Add that to the fact that astronomers around the world are all trying to book time on Webb, and you get an idea of how tough it is to study this planet in detail. That's why we haven't confirmed yet whether those massive oceans actually exist. But the research team who made this discovery is working hard to get more observation time. They believe with just a few more hours of Webb's precious attention, they could confirm the presence of water. If they do, it could mean we're looking at the most Earth-like exoplanet ever found. A super-Earth with a nitrogen-rich atmosphere and potentially life-filled oceans. Think about that. Not just a planet that could support life, but one that might already be teeming with it, swimming in its alien waters. But LHS 1140b isn't the only exciting super-Earth catching scientists' attention. In June 2024, another breakthrough made headlines. Astronomers from the University of St. Andrews revealed that they had discovered not one, but 3 super-Earths orbiting a nearby orange dwarf star just 55 light-years away. Among them, the third and farthest planet is situated in the star's habitable zone, the perfect spot where temperatures might allow liquid water to exist. And because orange dwarf stars are much more stable than many others, they don't bombard nearby planets with harmful radiation like some stars do. That stability is key. A steady environment gives life a chance to form and evolve. And all 3 of these newly discovered planets have masses ranging from 5 to 11 times that of Earth. That's right in the sweet spot, big enough to hold onto a thick atmosphere but not so massive that conditions become too extreme. Scientists are particularly interested in the third planet, which orbits the star every 151 Earth days. Could this be another Earth-like world? Maybe. And now, researchers are preparing to take a closer look using powerful techniques like high-contrast direct imaging and high-resolution spectroscopy. This is where the James Webb Space Telescope really shows what it can do. By analyzing light that passes through or reflects off a planet's atmosphere, scientists can figure out its composition, and maybe even detect signs of life. It's slow, painstaking work, but the payoff is incredible. Just imagine, A planet 55 light-years away in the habitable zone, possibly wrapped in clouds, with a surface that might host oceans, continents, and life forms no one has ever seen. We're not there yet, but for the first time, we're getting close to real answers to the question, are we alone? And the discoveries just keep coming. Webb's latest surprise is an actual direct image of a distant gas giant called Epsilon Indiub. This planet is located just 12 light-years away, practically our cosmic backyard. Using a special instrument called a coronagraph, the telescope blocked out the blinding light from the planet's host star, making it possible to see the planet itself. That's a huge deal. It's one thing to detect a planet by its effects on a star's light, but to directly see one? That's a level of clarity we've never had before. And what's even more surprising is the temperature. You might think a gas planet far from its star would be a frozen wasteland, like Neptune's icy moon Triton. But Epsilon Indiub is actually quite warm. Temperatures on the planet hover around 35 degrees Fahrenheit. That's about 180 degrees warmer than Jupiter, which is pretty shocking. And that warmer temperature opens up the possibility of complex atmospheric chemistry. Gases like carbon dioxide, methane, and carbon monoxide could exist in its clouds. And wherever these ingredients show up, there's always the faint possibility of life. Sure, it's a gas giant, but we've learned not to rule anything out anymore. And for those of you who are fans of science fiction, this might sound familiar. That's because Epsilon Indi has been featured in Star Trek, Halo, and other works of sci-fi for years. And now it's not fiction. We're actually finding real planets in this system. There's something deeply satisfying about watching science fiction slowly turn into science fact. We used to imagine these worlds. Now we're seeing them with our own eyes thanks to Webb. But if you think that's wild, wait until you hear about the so-called zombie planets. These aren't just exoplanets, they're some of the weirdest things in the galaxy. Imagine planets that roam the galaxy with no star to orbit. They're not tied to any solar system. They drift through space alone, and scientists now believe they formed the same way stars do, by collapsing clouds of dust and gas. But they're not stars. They didn't grow massive enough to ignite nuclear fusion. That's why astronomers call them zombie planets, star-like bodies that never quite came to life. Ray Gardner and his team at Johns Hopkins University discovered 6 of these bizarre objects in the NGC 1333 star cluster, about 960 light-years away. And they're absolutely huge. These rogue worlds are 5 to 10 times the size of Jupiter. But they don't orbit any star. They formed like stars, but they're just floating out there in the dark. That's why the line between planet and star starts to blur here. One especially strange case may even be forming its own miniature solar system. While the chance of life on these zombie planets is extremely low, they're still vital to understanding how the universe builds its worlds. They remind us that not everything fits neatly into our categories of planet or star. The cosmos loves to surprise us. And it doesn't stop there. The James Webb Telescope also discovered something just as strange. A zombie galaxy. This distant galaxy was believed to have died. It stopped forming stars about 20 million years ago. Scientists assumed it was a red and dead galaxy, drifting quietly through space. But then, Webb saw something astonishing. It was coming back to life. The galaxy had started forming new stars again. No one expected it. And just like that, a once-dead system was active again, teaching us that the universe has more second chances than we thought possible. Even dead galaxies can rise again. When scientists first observed this ancient galaxy, they made a surprising declaration. It was already dead. No new stars seemed to be forming. It was like staring into the grave of a cosmic giant. But that conclusion came with a catch. The light from this galaxy had taken billions of years to reach Earth, meaning astronomers weren't seeing it as it is today. They were seeing it as it looked just 650 million years after the Big Bang. This made it one of the oldest known galaxies ever observed. But something odd stood out. The galaxy had seemingly died, then mysteriously came back. Digging deeper into the data, astronomers discovered something astonishing. The galaxy showed clear signs of both very young stars and much older ones. This suggested a period of silence. After about 100 million years of forming stars, the galaxy suddenly went quiet for nearly 20 million years. Then, as if jolted awake, it began to birth new stars again in rapid succession. This strange stop-and-start behavior was completely unexpected. For a galaxy to die and then seemingly return to life is a phenomenon scientists had rarely seen before. It was a cosmic resurrection, and it raised big questions. And here's where things take a personal turn. It turns out our very own galaxy, the Milky Way, isn't so different. In fact, it's what scientists now call a zombie galaxy. Yes, we're living inside a galaxy that once died. According to groundbreaking research led by Japanese astronomer Masafumi Noguchi of Tohoku University, the Milky Way has had quite the dramatic life. Think of it like a giant living creature, going through active periods of creation followed by long periods of rest, before springing back to life again, like something out of a sci-fi resurrection story. Noguchi's research suggests that our galaxy formed around 10 billion years ago and went through two main phases of star production. During the first phase, cold gas from interstellar space flowed into the galaxy, fueling the birth of countless stars. Some of these stars exploded in massive supernovae, scattering critical elements like oxygen and magnesium across space. These explosions helped mix new materials with gas clouds, making even more stars. But then something shifted. Roughly 7 billion years ago, powerful shockwaves began heating the surrounding gas so much that it could no longer cool and fall inward. This intense heating caused a cosmic drought. For around 2 billion years, the Milky Way experienced a lull. No new stars were born. It was a long, quiet pause in the galaxy's history. However, all wasn't lost. During this still period, some of the remaining older stars began to reach the end of their lives, exploding into supernovae and pumping iron into the surrounding gas clouds. Then, about 5 billion years ago, the gas began cooling again and the galaxy returned to life. A second wave of star birth began, and among these new stars was the one we call the Sun. Our solar system was born during this second star-forming phase, meaning our entire existence might never have happened if the galaxy hadn't come back to life. These newer stars, including our Sun, were richer in heavy elements like iron, making them different from the first generation. This rebirth of the Milky Way shows how dynamic and unpredictable galaxies can be. Like a living organism, the galaxy has phases, rising, resting, and rebirthing again. We're literally part of a second-generation galaxy, living inside a resurrected giant that once stopped breathing stars, and then came back. Now, while the Milky Way continues its stellar journey, astronomers have found other fascinating systems with potential for life, like GJ 667, also known as Gliese 667. This star system, located in the constellation Scorpius, is just 23 light-years away. What makes it so intriguing is that it's a triple star system, 3 stars bound together by gravity. Among these, the third star, Gliese 667c, has planets that lie within its habitable zone, meaning these worlds could, in theory, support life. That's a pretty big deal in the search for extraterrestrial life beyond our solar system. Let's break this system down. Gliese 667a is the largest of the 3, a K-type orange-red dwarf star, about 73% the mass of our Sun and only 12% as luminous. It's joined by Gliese 667b, another K-type orange-red dwarf with slightly less mass and brightness. These two stars orbit each other at a distance of around 12.5 astronomical units, AU. But the most captivating star in this trio is Gliese 667c. It's a much smaller M-type red dwarf, just 1/3 the size of our Sun, with a cooler surface temperature of around 3,775 Kelvin. Despite its faintness and small size, Gliese 667c has captured scientists' attention because of its rich planetary system. Initially, researchers believed it hosted only 3 exoplanets. But further observations and data analysis revealed there might actually be 6, possibly even more. Most astonishingly, 3 or even 4 of those planets appear to be in the star's habitable zone. These aren't gas giants like Jupiter. They're rocky super-Earths, larger than Earth but much smaller than the massive gas planets. They could be made of rock or a mix of rock and ice, possibly with thick atmospheres, an exciting possibility for habitability. Take, for example, Gliese 667cb, the closest planet to the star. It's scorching hot, with surface temperatures soaring to around 200 degrees Celsius. It's also the most massive, about 5.5 times the mass of Earth, and orbits the star in just 7 days. That's way too close and too hot for life as we know it. But things get much more promising as you move outward. The next planet, Gliese 667cc, is right within the inner edge of the habitable zone. This super-Earth has a mass of 3.8 Earths, a radius 1.8 times larger, and completes an orbit in just 28 Earth days. Gliese 667cc is particularly fascinating because of its high Earth similarity index of 0.85, a very encouraging number for astronomers. It receives about 10% less visible light than Earth does from our Sun, but most of its radiation comes in the form of infrared light. That means even though it's dimmer, it could still provide enough warmth for water to exist on its surface, one of the key ingredients for life. But the planet is likely tidally locked, meaning one side always faces the star while the other remains in permanent darkness, creating a world of eternal day and eternal night. This type of planet poses unique challenges. If there's no atmosphere, the temperature contrast between the two sides could be extreme. However, if an atmosphere does exist and is similar to Earth's, it could help circulate heat around the planet, potentially leading to more stable, temperate conditions. Maybe even pleasant ones with average temperatures around 30 degrees Celsius on the night side. Living there would be strange. The skies would glow faintly red due to the star's lower energy output. Meanwhile, the other two stars, Gliese 667a and b, would appear like bright full moons in the sky, even during the day. But there's a potential danger too. Red dwarfs like Gliese 667c are known for their violent temperaments. They often emit powerful stellar flares, bursts of radiation and charged particles that can be up to 1,000 times stronger than those from our Sun. For any planet orbiting close to such a star like Gliese 667cc, these flares could be hazardous. Radiation storms might erode atmospheres or pose a threat to surface life. Additionally, Gliese 667c's magnetic activity may cause star spots, dark, cooler areas on the surface, that can reduce its light output by up to 40% for extended periods. All of these factors combine to create a very different world than what we're used to here on Earth. Gliese 667cc is also much heavier than Earth. That means the gravity on its surface is significantly stronger. If you weigh 75 kilograms here on Earth, you'd weigh about 120 kilograms there. Just standing or moving around would take more effort. Even though it's rocky like Earth, the stronger gravity would affect everything, from how high you can jump to how your body functions over time. It's a fascinating place, part paradise, part challenge, and full of scientific wonder. In addition to mass determining a planet's gravity, it also affects its ability to hold an atmosphere. A more massive planet can retain a thicker atmosphere, which directly leads to greater surface pressure. If this atmosphere is similar to Earth's, the pressure might only be a few times higher than what we experience. But if the exoplanet has a dense, Venus-like atmosphere, the surface pressure could skyrocket, reaching hundreds of times greater than Earth's, equal to the crushing pressure several kilometers deep in Earth's oceans. This could make survival conditions incredibly harsh, yet still not entirely impossible for life. Despite being located within the habitable zone, GJ 667cc may not provide Earth-like conditions. Life here would have to endure more than just differences in temperature. There would be periods of fluctuating or even consistently low light, extremely high atmospheric pressure, and potentially intense and frequent stellar flares. These challenges sound extreme, but on Earth, life has shown an incredible ability to adapt, even thriving in places with boiling temperatures, complete darkness, or crushing pressure. So the idea of life existing on GJ 667cc is not beyond reason, just one that would require far more adaptability than what we typically imagine. Two other planets in this system, GJ 667su and GJ 667cf, are also thought to be potentially habitable. Both orbit farther from their host star than planet CC, meaning they receive less energy. As a result, these planets could be too cold to support life as we know it. But this is where having a thick atmosphere would be beneficial. A dense atmosphere could trap heat, maintaining surface temperatures high enough for liquid water and possibly life. So, unlike with GJ 667cc, thicker atmospheres are a potential lifesaver on planets like Su and CF. Finding 3 potentially habitable planets within the habitable zone of one system is already a rare event. Finding 4 would be almost unthinkable. However, one study estimates that 5 planets in the GJ 667c system receive solar radiation anywhere between 20% to 200% of what Earth receives from the Sun. This wide range puts them all in the category of possible habitability, depending on various atmospheric and surface conditions. But habitability is never determined by sunlight alone. There are other complex factors that influence whether a planet can truly support life. Scientists have identified the inner and outer boundaries of the habitable zone around the GJ 667c star. For a planet with Earth-like mass, the inner boundary lies between 0.095 and 0.126 astronomical units, AU, while the outer boundary ranges from 0.241 to 0.251 Australian dollars. Any planet orbiting within this range might support life, assuming other conditions are right. Planets too close to the star experience a greenhouse runaway effect, where water vapor turns into a heat-trapping gas, raising temperatures beyond survivable levels and eventually driving all water off the planet. Planets on the inner edge of this habitable zone are especially vulnerable to this moist greenhouse effect, where trapped heat becomes uncontrollable. However, planets with larger masses are more resistant to this outcome, allowing them to hold on to their water for longer periods. On the other hand, planets too far from their star, like GJ 667g, risk being frozen worlds. While carbon dioxide in the atmosphere can help warm these distant planets, too much of it has the opposite effect, reflecting sunlight away and cooling the surface instead. It's a delicate balance between warmth and cold. In 2013, astronomers announced that the GJ 667c system likely contains at least 6 planets, with the possibility of a 7th. The potential 7th planet is known as GJ 667ch. If it exists, this exoplanet could be the smallest one orbiting the star, with a mass just slightly above Earth's, about 1.1 times greater. It sits between planets C and B. Due to its small size and close proximity to the parent star, GJ 667ch is most likely far too hot to support life, eliminating it from the list of potentially habitable worlds in this system. Among the planets orbiting in the habitable zone, F and E are confirmed, while D's position remains uncertain, though it may still fall within range. That means planets CC, CF, SU, and possibly even D all remain in consideration as candidates for supporting life. The discovery of this many potentially habitable planets in a single system is extraordinary. And since M-dwarf stars like GJ 667c are the most common type of stars in our galaxy, this suggests that densely packed systems with multiple habitable planets may be far more common than we previously believed. This changes the way scientists search for habitable worlds. Instead of analyzing 10 different stars to find just one Earth-like planet, researchers can now focus on one M-dwarf star and potentially find several candidates for Earth 2.0. This increases our odds significantly. With the rapid advancement of telescope technology, our capacity to explore and understand these alien systems is growing faster than ever. The mysteries of the universe, once unreachable, are becoming increasingly visible and measurable as our instruments become more precise and powerful with each new mission. The James Webb Space Telescope was initially designed to peer deep into the early universe and study the formation of the first galaxies and stars. But its true power lies in its ability to analyze the atmospheres of distant exoplanets. With its near-infrared spectrograph and mid-infrared instrument, JWST can detect the light signatures of chemicals in an exoplanet's atmosphere. This allows scientists to determine the composition and temperature of alien skies, and even identify signs of geological activity or potential biological processes occurring on planets dozens or hundreds of light-years away. JWST's advanced infrared camera can also see through thick cloud covers that would normally block telescopic observation. This is crucial for studying exoplanets with dense atmospheres, where light from their host star is filtered as it passes through. But the challenge arises with the nature of M-dwarf stars like those in the TRAPPIST-1 system. These stars are among the most active, regularly releasing powerful flares. Such stellar activity makes it difficult to distinguish between normal atmospheric light signatures and the noisy radiation produced by the star's surface eruptions. Despite that challenge, JWST's sensitivity is unmatched. Its precision is so extreme that it can detect brightness changes comparable to noticing 4 light bulbs turning off in a room filled with 10,000 bulbs. This level of detail allows astronomers to pick up minute variations and study exoplanets in ways that were previously impossible. The TRAPPIST-1 system is a perfect example. Recent data shows the innermost planet, TRAPPIST-1b, has either a very thin atmosphere or none at all, making it a superheated rocky world with surface temperatures reaching 450 degrees Fahrenheit, far too hot for life as we know it. The second planet in this system, TRAPPIST-1c, was once thought to be similar to Venus, potentially with a thick, heat-trapping atmosphere. But JWST proved otherwise. This planet lacks a Venus-like atmosphere, and though still scorching at about 225 degrees Fahrenheit, it's now considered the coldest rocky planet ever studied using this method. Under these extreme conditions, any water that once existed would have evaporated long ago. Still, the farther out planets in the system may have remained cold enough to retain water, either as ice or in some stable liquid form protected by atmospheric or orbital conditions. Among them, TRAPPIST-1d is the lightest, with only 30% the mass of Earth and a radius just 80% of Earth's size. Due to this low mass, the planet likely lacks a dense atmosphere and doesn't have an abundance of heavy elements. However, it still receives a similar amount of solar energy as Earth does. Located on the inner edge of the habitable zone, its surface temperature without an atmosphere would hover around 48 degrees Fahrenheit. For comparison, if Earth didn't have its greenhouse effect, our planet's surface would average 0 degrees Fahrenheit, well below freezing. One of the most intriguing aspects of TRAPPIST-1d is its potential water content. Scientists believe this planet could harbor as much as 250 times more water than Earth. While this doesn't confirm habitability, it's a striking number. One key factor that may influence whether the planet avoids a runaway greenhouse effect is its albedo, a measure of how much light a surface reflects. Earth's average albedo is about 0.3. If TRAPPIST-1d shares a similar value, it would reflect enough sunlight to stay cool enough for liquid water, avoiding the fate of turning into a superheated, uninhabitable world. Albedo is a crucial component in planetary climate. It's measured from 0 to 1, with 0 being a perfectly black surface that absorbs all light, and 1 being a perfect mirror that reflects all radiation. A planet with an Earth-like albedo would strike a balance, retaining enough heat to avoid freezing but not so much as to overheat. For TRAPPIST-1d, this makes a huge difference. Even with its limited mass and thin atmosphere, a suitable albedo value could make it comfortable enough for basic life forms to survive, provided other conditions also align just right. Scientists also speculate that TRAPPIST-1d may be covered by a vast global ocean. But for any potential life in that ocean to thrive, it would need more than just water. It would require a heat source. This is where tidal heat flux comes into play. It's a special kind of internal energy generated by gravitational interactions with other nearby planets and the host star. On TRAPPIST-1d, this tidal heating could mimic the geothermal processes we see on Earth, fueling underwater chemical reactions and potentially sustaining microbial or even more complex forms of alien life. Even here on Earth, there are forms of life that don't depend on sunlight. Deep beneath the ocean, around hydrothermal vents, entire ecosystems thrive purely on chemosynthesis, drawing energy from chemicals instead of light. So if that can happen on our planet, it opens the door to the idea that TRAPPIST-1d could also support similar life forms. If TRAPPIST-1d has a thin atmosphere, it's possible that the twilight zone, where perpetual dusk separates the scorching day side from the frozen night side, could offer just the right conditions for survival. It might be a narrow band, but it could be a lifeline for life. Among all the 7 planets in the TRAPPIST-1 system, the fourth one, TRAPPIST-1e, stands out as the most promising. It's both dense and possibly rocky, and its composition appears strikingly similar to our own planet. Sitting in the habitable zone of its parent star, TRAPPIST-1e may have once held more water than either Earth or Mars, and if it retained enough of it, then its climate might closely resemble what we enjoy here. Scientists even believe it could have developed a thick, oxygen-rich atmosphere after shedding lighter elements like hydrogen. Good news, since hydrogen acts as a greenhouse gas and could have made things uninhabitable. What makes TRAPPIST-1e even more fascinating is its potential to be one of the most Earth-like exoplanets ever found. But life there would be very different. A year would last only 7 Earth days, and the whole idea of day and night would feel unfamiliar. That's because all 7 planets in the TRAPPIST-1 system are tidally locked. One side always faces the star. On TRAPPIST-1e, that means one half lives in eternal sunlight, and the other in permanent darkness. In the twilight regions between, you'd experience a never-ending sunrise or sunset, painting the sky with a reddish glow. Standing on the day side of TRAPPIST-1e, you might witness massive storm systems and dust clouds sweeping across the surface, acting as a giant heat distribution system. This constant atmospheric motion could actually help stabilize the planet's temperature, making it more livable than you'd expect. The other planets would appear in the sky like oversized moons, 6 celestial neighbors sharing the same orbital dance, some even larger in the sky than our moon. It's a surreal vision, a constant reminder that you're part of a tightly knit cosmic family circling a dim red sun. But the dark side of the planet? That's a very different story. It's a place of deep freeze, dominated by glaciers and freezing winds that sweep across the barren landscape. Venturing there would be like entering the Arctic on steroids. Still, this eternal twilight has a surprising benefit: navigation. Because the TRAPPIST-1 star always hangs in the same place in the sky, explorers would have a fixed point for orientation, like having a permanent North Star to guide you through alien lands, making early exploration and settlement just a little less daunting. Though the star might seem small, it's not to be underestimated. In fact, there are 10 times more of these red dwarf stars in our galaxy than stars like our Sun. That means red dwarfs like TRAPPIST-1 could be key players in the search for life beyond Earth. And because they live so much longer, trillions of years compared to the Sun's 10 billion, they offer plenty of time for life to emerge and evolve. But there's a catch. While red dwarfs are normally calm, they can suddenly erupt in powerful solar flares, sending out intense bursts of radiation. Some researchers think these solar flares could have actually played a role in kickstarting life. The bursts of energy might help form complex organic molecules like amino acids, the very building blocks of life. Of course, too much radiation can be deadly. It could strip away a planet's atmosphere or sterilize the surface entirely. Thankfully, TRAPPIST-1 seems to be a relatively quiet star. Its flares are about 30 times less intense than those of other red dwarfs, which makes the whole system a more stable place to look for life. Still, the danger isn't gone. Because the planets are packed so tightly together, even mild flares can affect all of them. TRAPPIST-1e might experience auroras unlike anything on Earth, vast glowing curtains of light that serve not just as a spectacle but a warning. These auroras could act like alarms, signaling that radiation is on its way. In such a world, survival would depend on shielding, both natural and artificial. A thick ozone layer, a strong magnetic field, and advanced tech to detect flares in advance would be critical. Colonists would likely live in reinforced shelters, possibly underground, to stay safe during these cosmic storms. These habitats would need to be more than just homes, they'd be bunkers. Built with radiation-resistant materials and equipped with life support systems, they'd provide safe zones during flare events. Without proper protection, exposure could cause arteries to contract, leading to serious health risks. The DNA in our cells could also be damaged, potentially causing long-term health issues or even deadly mutations. Even though gravity on TRAPPIST-1e is 93% that of Earth, making everyday movement relatively easy, the threat from radiation would force humans to plan every outdoor step with caution and preparedness. Growing food would be another massive challenge. With a constant low-angle glow from the red dwarf star, light would be limited and uneven, casting long shadows across the terrain. Traditional farming methods wouldn't cut it. Instead, settlers might turn to vertical farming systems inspired by the Hanging Gardens of Babylon. Imagine multi-tiered platforms stacked with vegetation, each level angled just right to catch what little sunlight filters through. This tiered design would allow light to reach lower levels, even in the dim twilight, maximizing every ray for plant growth. These artificial gardens would mimic nature's own vertical strategies, like how plants grow up trees or cling to rocky cliffs to reach the light. And if native plant life does exist on TRAPPIST-1e, it might be completely black in color to absorb more sunlight. Some of it might even glow, bioluminescent life forms lighting up the dusk with their own gentle shine. This glow could help the plants extend their photosynthesis beyond normal light hours, creating ecosystems uniquely adapted to their world of constant twilight. It's an adaptation that's not just beautiful, but potentially life-saving. Moving farther from the star, we find TRAPPIST-1f. It receives only about 1/3 the light Earth gets, making it much cooler. If it lacks an atmosphere, the surface could drop to an icy -74 degrees Fahrenheit, turning any water into solid ice. The outer planets, TRAPPIST-1g and TRAPPIST-1h, face even colder conditions. TRAPPIST-1h, for example, might plunge to -148 degrees Fahrenheit. Yet even in this frozen frontier, hope lingers. TRAPPIST-1g is more massive than Earth, meaning it could hold onto an atmosphere that insulates its surface, especially if it has volcanic activity providing the gases needed to sustain a greenhouse effect. If TRAPPIST-1g has retained this atmosphere, it might be a water world beneath the ice. Some scientists suggest that if liquid oceans exist, they could be over 4,000 meters deep, almost twice the average depth of Earth's oceans. In those hidden depths, alien life might thrive, shielded from radiation by thick layers of ice and rock. It's a compelling idea. Life not on the surface but in vast underwater worlds, isolated yet possibly teeming with microscopic organisms or even complex ecosystems, all hidden beneath a frozen shell that protects them from the harsh surface above. At the far edge of the system lies TRAPPIST-1h. It barely gets any light at all. If it orbited in our solar system, it would be somewhere between Mars and Jupiter, deep into the cold zone. This frozen world gets so little energy that it remains locked in deep freeze, a place where the surface likely never thaws. But there's something else to consider. TRAPPIST-1 itself. It's an old star, 7.6 billion years old and cooling ever since it formed. Long ago, its heat could have vaporized water on nearby planets, causing it to gather in the atmosphere before being swept away by stellar winds. This raises a puzzle. If the early heat stripped away water, how could any planets retain moisture now? Recent models suggest a surprising answer. Unlike what scientists once believed, heat doesn't always escape through convection. Planetary atmospheres are more complex, with gases acting differently at varying altitudes. So even if a planet faced harsh early conditions, water might not have vanished completely. Some of it could remain trapped within the rocks, hidden beneath the surface, waiting for a time when conditions stabilize. This means TRAPPIST-1's planets might still hold the ingredients for life, just not where we expect them. Despite the current extremes, boiling on one end and freezing on the other, the TRAPPIST-1 planets have time on their side. Red dwarfs like TRAPPIST-1 burn slowly and live for trillions of years. That's an enormous cosmic time scale, allowing these planets to go through countless cycles of change. A scorching world today might be lush and mild a billion years from now. A frozen wasteland could thaw into a habitable ocean planet. And one of these strange alien worlds might someday become a second home for humanity, or even cradle entirely new life. Many studies over the years have suggested something fascinating. Life may actually be more likely to emerge around red dwarf stars than stars like our own Sunday. This isn't just a random idea, it's backed by real astronomical data and statistical models. Red dwarfs are not only the most common type of star in our universe, but they're also the smallest kind of hydrogen-burning stars. That makes them interesting targets in the search for alien life. Their small size and long lifespan create a stable environment, which is exactly what developing life might need to thrive over billions of years. In 2023, astronomers stumbled upon an exciting new exoplanet orbiting one of these red dwarfs. The star is named TOI 715 and it's located in the constellation Volans, about 136 light-years away. In astronomical terms, that's surprisingly close, almost like the cosmic equivalent of a house down the street. The planet orbiting this star is called TOI 715b, and it's what scientists refer to as a super-Earth. This term simply means it has a mass larger than Earth's but still potentially retains a rocky composition. Specifically, TOI 715b is about 3 times as massive and roughly 1.5 times the size of Earth. For any exoplanet to be considered potentially habitable, it needs to meet some specific criteria. One of the biggest factors is its physical makeup. It has to be either a rocky planet like Earth or a water world, something that could possibly host oceans. By closely analyzing TOI 715b's measurements, scientists can estimate what this planet is made of. Its size and density suggest that it probably isn't a gas giant. Instead, it's more likely a rocky world with a solid surface. And that's exactly the kind of planet that makes astronomers sit up and take notice when searching for life. But the true excitement around TOI 715b comes from more than just its mass and size. It's located at what scientists call the Goldilocks zone. Not too hot, not too cold, just the right distance from its star to allow liquid water to exist on its surface. Since liquid water is considered one of the main ingredients for life as we know it, this increases the planet's habitability score by a lot. It's this balance of temperature, size, and composition that makes TOI 715b such an intriguing discovery. It may just be one of the most promising exoplanets we've found so far. Red dwarfs like TOI 715 often host tightly packed planetary systems, with multiple planets orbiting within the habitable zone. In fact, some astronomers believe there's another planet in this system, one that might be just slightly larger than Earth. If confirmed, it would become the smallest planet ever discovered within a habitable zone by NASA's Transiting Exoplanet Survey satellite, TESS. This adds even more excitement to TOI 715's neighborhood. Every new planet in such a system increases the odds that at least one of them might host life or at least have conditions friendly to biology. Even though we still know very little about TOI 715b and its possible neighbors, the idea of a rocky super-Earth sitting in the habitable zone is thrilling. What if future missions detect an atmosphere around it? Or maybe even surface features like lakes, clouds, or weather patterns? Scientists compare it to Saturn's moon Titan, which has rivers and lakes of methane. Now imagine something similar, but with water, and potentially even life. If such discoveries happen, this planet could become one of the top candidates for future exploration, or even remote observation missions that look for biosignatures. Imagine the future. Our descendants traveling across the galaxy, navigating alien landscapes that we can only dream of right now. Vast valleys, towering cliffs, strange oceans, and creatures we've never imagined could await us on planets like TOI 715b. What might they see? What might they learn? The idea that we could one day explore such places is no longer just science fiction. Thanks to new discoveries, it's starting to feel possible. But not all exoplanets are so welcoming. In fact, most of them seem downright hostile to life, with temperatures and environments that boggle the imagination. Some exoplanets are so bizarre they raise more questions than answers. Take LTT 9779b, for example. This exoplanet sits about 264 light-years from Earth and belongs to a rare class known as ultra-hot Neptunes. These planets are extreme in every sense. LTT 9779b is about 5 times the size of Earth, but what really makes it stand out is how reflective it is. In fact, it's the most reflective exoplanet we've ever discovered. This strange world reflects nearly 80% of the light that hits it, turning it into what scientists are calling a cosmic mirror. To put that into perspective, Earth reflects only about 30% of the sun's light. So how is this distant planet bouncing back so much radiation? The secret lies in its atmosphere, which is packed with reflective clouds made of metals. Yes, you heard that right, clouds of metals like titanium that even rain down as droplets from the sky. It's one of the strangest weather systems we've ever come across. But here's the kicker: by all known models, LTT 9779b shouldn't even exist. Its proximity to its star should have stripped away its atmosphere long ago. Researchers compare this bizarre phenomenon to what happens in a steamy bathroom. If the air gets too saturated with vapor, condensation begins. Something similar might be happening here. As the atmosphere heats up, silicate and metal vapors may form on the planet's day side. But somehow reflective metal clouds still manage to exist. The reflectivity may actually be helping the planet survive, by bouncing back light and preventing itself from overheating. Without this mirror-like effect, LTT 9779b could have slowly evaporated away into space. Instead, it remains a glittering enigma orbiting its star at breakneck speed. This exoplanet is especially unusual because it fills a missing gap in our planetary catalog. Scientists have observed many exoplanets that orbit their stars in less than one Earth day, but they're usually either massive hot Jupiters or tiny rocky worlds. There's been an odd absence of Neptune-sized planets in this range, and astronomers refer to this as the Neptunian desert. LTT 9779b is the first of its kind discovered in this region, finally giving us insight into a type of planet we previously thought might not exist. It's an ideal target for future observations by Hubble and James Webb. And speaking of strange worlds, there's another one that's both terrifying and fascinating: WASP 76b. This planet was discovered over a decade ago, but recent studies have uncovered some jaw-dropping details. WASP 76b is nearly twice as wide as Jupiter, though it has only about 90% of Jupiter's mass. It orbits its star at an incredibly close distance, only 3% of the distance between Earth and the Sun. To compare, Mercury, our closest planet to the Sun, is located 10 times farther out. This planet is so hot, human bones would vaporize instantly on its surface. One side of WASP 76b is permanently facing its star due to tidal locking, meaning the other side is always in darkness. This leads to extreme temperature differences across the planet. Scientists have discovered at least 11 different elements in its atmosphere, many of them typically found in rocks on Earth. But in WASP 76b's blazing temperatures, these rock-forming materials vaporize into gases. Strong winds then carry these vaporized metals from the day side to the night side, where they cool down and condense. The result? Showers of molten metal rain falling from the sky, a vision both beautiful and terrifying. Adding to its bizarre resume, researchers have found unusually high levels of nickel in WASP 76b's atmosphere. This could suggest that in its past the planet may have consumed a smaller rocky planet, possibly something like Mercury. The presence of nickel points to violent planetary history and helps scientists understand how such exoplanets form and evolve. WASP 76b may not be habitable, but it shows just how diverse and dramatic alien worlds can be. It's a reminder that while some planets may resemble Earth, others are like fiery furnaces with alien weather unlike anything we've ever seen. Another recent and extraordinary discovery came from just 100 light-years away. Astronomers found a rare planetary system named HD 110067 that consists of 6 sub-Neptunes, planets 2 to 3 times the size of Earth. All of these planets are located unusually close to their host star. Their entire orbits fit within the space between Mercury and the Sun. But what makes this system truly fascinating is its age and stability. Unlike many young systems that change over time, HD 110067 has maintained its orbital structure for more than 1 billion years. The planets are locked in a perfect gravitational rhythm. This kind of orbital synchronization is called resonance, and it's incredibly rare in exoplanet systems. Imagine it like a celestial dance, each planet following a precise mathematical pattern. For example, when the first planet completes 3 orbits, the second planet completes exactly 2. This continues throughout the system, creating a chain of perfect timing. Usually, these delicate configurations fall apart due to gravitational disturbances or nearby massive objects. But HD 110067 has managed to stay in sync for a billion years, which tells scientists something very important about the stability and formation of such rare systems. The Hubble Space Telescope has once again surprised astronomers, this time with an astonishing discovery about an exoplanet known as GJ9827b. This planet is about twice the size of Earth and has temperatures similar to Venus, making it an extremely hot world. Under such conditions, most scientists wouldn't expect to find any trace of water, which is essential for life as we know it. But after observing this planet for over 3 years and watching it cross in front of its host star during 11 transits, Hubble detected clear signatures, fingerprints, of water molecules in its atmosphere. This finding is monumental because if the data is accurate, GJ9827b could become the first planet where scientists directly confirm the presence of water-rich atmospheres around stars that are very different from our own Sun. Theories suggest this planet might have formed far away from its current location, in a much colder region of space. Back then, water would have existed as ice. Over time, the planet slowly migrated closer to its host star, and due to intense radiation, it began losing hydrogen while retaining traces of water. Alternatively, GJ9827b might have formed near its hot star right from the beginning, with water already present in its atmosphere. Even if that's true, the environment on this planet is far from hospitable. The extreme heat means life as we know it couldn't survive there. Still, the presence of water alone makes it a remarkable target for further research. Now scientists eagerly await data from the James Webb Space Telescope, hoping it can give us even clearer insights into the nature of these steamy, water-rich worlds beyond our solar system. Meanwhile, the search for truly habitable exoplanets has taken a new turn. A recent study introduced a method based on carbon monoxide buildup in planetary atmospheres. When carbon monoxide accumulates faster than it can be broken down or removed, a process called CO runaway, it might influence the emergence of life. This concept could help researchers zero in on planets where Earth-like life is more likely to exist, especially those orbiting stars similar to our Sun. Across the Milky Way galaxy, it's estimated that there could be as many as 40 billion such potentially habitable planets. By closely studying the atmospheric chemistry of distant planets, astronomers can now focus their attention on the most promising candidates. In their quest to discover Earth-like worlds, scientists look for planets that closely match Earth's size, composition, and orbital conditions. A true Earth twin would have to be a rocky planet of similar mass, orbiting a Sun-like star, and located within the so-called Goldilocks zone, a sweet spot where temperatures allow liquid water to exist on the surface. One of the most compelling examples of this kind is Kepler 452b. Discovered back in 2015, Kepler 452b was hailed as the most Earth-like exoplanet ever found at the time. It orbits a G-type star, just like our Sun, with nearly the same surface temperature. However, Kepler 452 is about 1.5 billion years older and slightly bigger and brighter. The planet itself is about 60% larger than Earth, and although we can't say for certain, there's a good chance it's a rocky world. It lies within the habitable zone of its star, at a distance only about 5% greater than the distance between Earth and the Sun. What makes Kepler 452b even more intriguing is its long-standing position in the habitable zone. Scientists estimate it has spent at least 6 billion years in that perfect region, possibly long enough for life to develop, evolve, and perhaps even thrive. That, of course, assumes all the other conditions were right. Recent research offers even more hope, suggesting that if the planet has CO2 levels similar to those found on Earth, then Kepler 452b could indeed be a habitable world. But what would it be like for humans to live there? Given that Kepler 452b is larger and more massive than Earth, its surface gravity would also be stronger. That means any human setting foot there would feel about twice as heavy. It wouldn't be easy at first. People would struggle to move the way they're used to, and simple tasks would feel exhausting. But just like athletes train with heavy gear or firefighters carry weight, our bodies would eventually adapt. Stronger bones, tougher muscles, and more resilient cardiovascular systems would develop over generations, producing a new breed of humans well-suited for life on this heavier world. Despite the stronger gravity, life on Kepler 452b might still feel strangely familiar. Its proximity to a Sun-like star means it would receive sunlight and heat levels comparable to what we experience on Earth. Plants, if they exist, could rely on photosynthesis just like on our planet. The environment might include liquid water, thick clouds, and maybe even volcanic activity shaping the landscape. Many scientists now consider Kepler 452b a leading candidate for Earth 2.0, but it might not stay that way forever. In about 500 million years, researchers believe it could undergo a runaway greenhouse effect. This is the same phenomenon that turned Venus into a blistering inferno. As more and more carbon dioxide gets trapped in the atmosphere, the greenhouse effect intensifies. Eventually, it could make Kepler 452b's atmosphere 90 times thicker than Earth's, choking out any chance for life. Fortunately, that transformation is far off. 500 million years gives humanity a massive head start. If we ever colonize this world, there's plenty of time to make it our home and adapt before it becomes uninhabitable. Even so, distance remains a huge obstacle. Kepler 452b is located 1,800 light-years away from Earth. That number is hard to wrap your head around. Even the fastest object humans have ever built, the Parker Solar Probe, wouldn't be fast enough. It travels at a blistering 120 kilometers per second, an incredible feat of engineering. But even at that record-breaking speed, it only reaches 0.063% of the speed of light. If we used that probe to reach Kepler 452b directly, the trip would take an unbelievable 2.8 million years. It's a reminder of just how vast our universe is, and how much more we still have to learn and explore. There are other promising Kepler discoveries as well, and not all of them are quite so distant. Take Kepler 186f for instance. Located around 500 light-years away in the constellation Cygnus, it holds a very special place in astronomical history. That's because Kepler 186f was the first Earth-sized exoplanet ever found in the habitable zone of a distant star. Since that discovery, astronomers have grown more confident that many similar worlds exist throughout the galaxy. Kepler 186f is only slightly bigger than Earth, by less than 10%, making it an extremely intriguing candidate for further study. The planet completes one orbit around its red dwarf star every 130 days and lies on the outer edge of the habitable zone. That means it receives about 1/3 of the solar energy that Earth gets from the Sun. Its environment might be colder, more like Mars. But in this case that might be a good thing. Red dwarf stars are notorious for their violent solar flares, which can blast nearby planets with deadly radiation. Luckily, Kepler 180 SIXS star is smaller, cooler, and less active, meaning the planet might be far enough away to escape the worst of that danger. But distance alone isn't everything. Whether liquid water, and possibly life, can exist on Kepler 186f depends a lot on the planet's atmosphere. While its location suggests water might be frozen, the planet's relatively large size means it could have a thick atmosphere that traps heat efficiently. That could help maintain temperatures suitable for liquid water. The system also contains 4 other planets, but they're much smaller and orbit far closer to the star. Because of that, they're likely scorching hot and uninhabitable. Kepler 186f stands alone as the most viable world in the system for life. Of course, even Kepler 186f is still incredibly far by human standards. Using today's technology, it would take around 780,000 years to travel there. But let's imagine a future where humanity masters near-light speed travel, say 90% the speed of light. In that case, we could reach Kepler 186f in about 550 years. That's long, but it's not impossible. In the distant future, our descendants might one day walk on the surface of this alien world, experiencing sunlight from a red star and a sky entirely different from our own. The first step is always imagination, then exploration. Like the red dwarf star Kepler 186, which is much smaller and emits about 25 times less light than our Sun, the environment of its orbiting planet is quite different from what we experience here. If you were standing on the surface of this exoplanet at midday, the brightness of the sky would appear similar to how our Sun looks about an hour before sunset on Earth. It's not as blindingly bright, but still enough to light up the world around you. Interestingly, scientists say that this exoplanet maintains a stable axial tilt, which is crucial for consistent seasons and climate stability. This stable tilt has remained unchanged for tens of millions of years, a fact that excites scientists. A planet's axial tilt plays a major role in determining its habitability. When a planet wobbles too much, it can undergo extreme climate shifts, turning a once habitable environment into a frozen or scorched wasteland. Just look at Mars. Its unstable tilt over geological time likely contributed to its barren, dry state today. For Kepler 186f, however, this long-term tilt stability means that it could have seasons and weather patterns not unlike Earth's, making it a prime candidate in the search for habitable worlds. But the hunt for a truly Earth-like planet doesn't stop there. Some of the most promising candidates have been discovered completely by accident. In 2020, scientists reanalyzing old telescope data stumbled upon Kepler 1649c, a planet that had been previously marked as a false positive. This surprise discovery instantly caught attention. While we still don't know a lot about its atmosphere, what's striking is that this planet receives around 75% of the starlight that Earth does. And since it completes an orbit in just 19.5 days, scientists think its surface temperatures could be similar to what we experience on Earth. Of course, atmosphere plays a key role in making a planet livable. For instance, if Kepler 186f didn't have a heat-trapping atmosphere, its surface temperature would plunge to about -38 degrees Fahrenheit. That may sound frigid, but consider this. Without greenhouse gases, Earth would sit at a chilly 0 degrees Fahrenheit. In other words, even planets with similar solar exposure need the right kind of atmosphere to make them truly Earth-like. Kepler 186f would need significantly more greenhouse gases than Earth just to reach a temperature range where life could potentially exist. So temperature alone isn't enough to call a planet habitable. There are many other worlds in the universe that mirror Earth in terms of size or temperature. Planets like TRAPPIST-1f, TRAPPIST-1d, Teegarden Star C, and TOI 700d are a few such examples. What makes them extra special is that they're located relatively close to Earth in cosmic terms. However, Kepler 1649c still stands out. Even though it's located a daunting 470,000 light-years away and unreachable with current technology, it offers a fascinating mix of Earth-like traits that we haven't found in planets nearby. This makes it one of the most extraordinary discoveries in the field of exoplanet research. What's even more exciting is that Kepler 1649c has a neighboring planet, Kepler 1649b, which is about 8% larger than Earth but orbits much closer to the red dwarf star. Because of the strange 4:9 orbital ratio between these two planets, astronomers suspect there might even be a third as yet undetected planet in the system. If that's true, it would add another layer of intrigue to this system. With upcoming next-generation telescopes like the James Webb Space Telescope, we'll soon be able to gather more detailed clues about the atmospheres and surfaces of these worlds. Another intriguing world worth exploring is located about 1,100 light-years away in the constellation Lyra. This exoplanet, known as Kepler 442b, completes an orbit around its star every 112 days. It orbits a K-type star, cooler and smaller than our Sun, at about half the distance Earth orbits the Sun. While being this close to a star might seem dangerous, in this case it's actually optimal. The planet is just outside the danger zone where tidal locking might occur. That means it might rotate like Earth instead of always showing the same face to its star. That's important because tidally locked planets tend to have extreme climates, scorching on one side and frozen on the other. Kepler 442b's host star is dimmer and more stable than our Sun, which provides a more balanced environment for the planet. In fact, K-type stars are considered a sweet spot for habitability. They live longer than G-type stars like our Sun and aren't as volatile as M-type red dwarfs. Even better, they remain stable for tens of billions of years, giving planets orbiting them plenty of time to develop and sustain life. Within just 100 light-years of our solar system, there are believed to be over 1,000 K-type stars. These orange dwarfs can shine for up to 45 billion years, far outliving our Sun's 10 billion-year lifespan. During that time, they only grow about 10 to 15% brighter. Compare that to our Sun, which is expected to make Earth uninhabitable within the next 1 to 2 billion years as it becomes hotter. That makes planets like Kepler 442b, orbiting more stable stars, highly promising candidates in the search for long-term habitable worlds. To evaluate how Earth-like a planet truly is, scientists use various ranking systems. One of the most advanced is the Comparative Habitability Index, which improves upon older systems by combining multiple critical factors. These include whether a planet is rocky, how circular its orbit is, and how much sunlight it reflects, known as its albedo. All these elements influence the planet's temperature, climate stability, and its potential to support life. Kepler 442b scores an impressive 0.84 on a scale from 0 to 1, indicating a high potential for habitability. Despite that, we can't yet directly observe Kepler 442b with current telescopes. It's simply too far and too faint. To reach it with the fastest spacecraft we've ever built would take a mind-boggling 1.7 million years. That doesn't mean we're out of options though. Studies have shown that Kepler 442b receives just the right amount of radiation to possibly support a biosphere. Instruments like the James Webb Space Telescope could potentially detect signs of life, such as atmospheric gases, from afar. And while we're at it, JWST could also examine other promising exoplanets in the same part of the sky. In the Kepler-62 star system, located in the same constellation, scientists have found two more planets, Kepler-62e and Kepler-62f, that fall within the habitable zone. The other planets in the system orbit too close to their star and are too hot to support life. But Kepler-62e and 62f are fascinating. They're likely water-rich worlds with Earth similarity scores of 0.83 and 0.69 respectively. Kepler-62e completes one orbit every 122 days, while Kepler-62f takes 267 days. That puts both within a comfortable range for maintaining stable temperatures. What's truly exciting about Kepler-62e is the belief that it has a thick, cloudy atmosphere. This could create a warm and humid environment across the entire planet, even its polar regions. That makes it an exceptionally favorable place for life to thrive. Back in 2014, a study even suggested the possibility of a large moon orbiting Kepler-62e. If confirmed, that would increase the odds of habitability. Moons help stabilize a planet's rotation and axial tilt, which in turn ensures consistent climate and seasons. They also shield planets from asteroid impacts, which could otherwise wipe out life. Meanwhile, Kepler-62f, being farther from its star, is colder but still intriguing. Its surface conditions might not be ideal for human life, but that doesn't mean life can't exist. The main challenge is imagining how an advanced civilization could evolve there without access to land-based metals or even fire. These are critical elements for developing tools and technology. However, nature often surprises us. Perhaps intelligent life underwater could find creative ways to advance, using biology or chemistry in ways we haven't yet imagined. If humanity ever wanted to send a physical message aboard a spacecraft like the Parker Solar Probe to these planets, it wouldn't arrive for over 1.8 million years. A radio message, on the other hand, would get there much faster, in about 1,200 years. That's practically the blink of an eye on a cosmic scale. Kepler-62e and 62f may not be exact Earth twins today, but that doesn't mean they won't become more Earth-like in the future. Planetary systems are dynamic, and just as Earth has evolved over billions of years, so might these distant worlds. Remember, Earth itself was once a water-covered ball with no continents or breathable atmosphere. Over time, life changed the planet, shaping it into the diverse world we know today. Scientists speculate that the same transformation could be happening, or could happen, in places like Kepler-62e and 62f. These planets may eventually balance land and ocean in a way that fosters complex life. And if life already exists there, it could be more bizarre and advanced than anything we can currently imagine. Just think, we have flying fish on Earth. Who knows what's swimming or flying out there? One of the biggest obstacles to learning more about these distant worlds is, of course, the distance itself. But even without breakthrough propulsion or ultra-powerful telescopes, we're still making remarkable progress. Data from Kepler and the European Space Agency has revealed that about half of all Sun-like stars could host rocky planets in their habitable zones. Even more thrilling, many of these stars could be relatively close to us, possibly within just 20 light-years. That gives scientists a 95% confidence that a twin Earth is hiding somewhere nearby. So the big question remains, how long will it take before we find a truly habitable planet close to our solar system? And more importantly, how will that discovery reshape the future of humanity? Will it unite us in our common goal of exploration, or lead to new questions about our place in the cosmos? Let us know your thoughts in the comments, and don't forget to stay tuned as we continue our journey through the universe, searching for worlds that might one day become our second home. Thanks for watching.